Hello class. Good. Yes, have you all? Am I audible and visible? Hello everyone. All right, wait for a moment. Yes, good afternoon all of you. Good afternoon. Welcome back again. Hello Embibers. How you all? All good and fine. कैसे आप लोग? This is Sheikh Rafique for you. Yes, क्या आपको मेरी आवाज आ रही है? Am I audible and visible? Just let me confirm in a chat box, all of you. Hello everyone. Yes, just subscribe the channel, obviously. All right, Harsha. Thank you so much for your confirmation. Yes, जल्दी से जुड़िए सभी लोग. Just connect here. And those who are waiting, just share the video so that more and more can join. Good afternoon all of you. Good afternoon. Yes, hello everyone. Good afternoon. I hope you all have a good day, great day here. So this is Sheikh Rafique here. So yes students, today we are going to learn about limits and continuity. All right. Yes, I know that the chapter is a little bit lengthy, like a limit, continuity, this differentiability as well is there. So in one shot, we have just limit and continuity today here. We have a various type of question, various type of problem like from last 2 to 3 years. Okay, Harsha, all right. Okay, thank you so much. So from last 2 to 3 years, we have a kind of a problem like which are like we can say latest problem. Yes, those are in a trending. Clear? Yes, like a trending problem we have here. So let's take a look here one by one here. But before we start the session, what we have right now. Yes, this is about myself. I have experienced more than 6 years. Yes, already maintained 10,000 plus students here. And what next? Exactly. 3 important application. Embibe Really app, Embibe application and Embibe Lens app. You know the importance of Embibe Lens app. What are the importance of Embibe Lens app? You know that. Like if you want to see the 3D visualization, yes, simply click the picture, you will get all the information as well as the 3D model of it. Like in a mathematics, if we talk about in a mathematics, if you have a like a 3D geometry, the chapter 3D geometry, yes, you can click the picture of a question and you will get what? All those figure. Clear? All right. One more thing. Yes, if you have a doubt, you can join our WhatsApp channel as well as Telegram channel. The link is already given in a description. Yes, kindly join it. Whatever we have done entire throughout the classes, everything will be available there. Yes, even the notes as well as the question here. Clear? All right. So try to join it. What next? Yes, regarding the batch here. Take a look here. Yes, Drona batch JEE 2024 here. Yes. So kindly note down the timing of mathematics here. Yes. Take a look here on Embibe application, that is on Tuesday 6 p.m. then Friday 6 p.m. and Saturday we will discuss what? Mock test discussion. Yes, a mock test discussion which is you have already given. We will discuss Saturday 3 p.m. as well as on yes YouTube also. Take a look here, the YouTube timing here. Take a look here. The YouTube timing as well. Yes, take a look here on Monday 2 p.m. then Wednesday 3 p.m. Yes, that means today, Thursday again, tomorrow 2 p.m. Yes, so 3 days on application and 3 days on where? YouTube. Okay, so let's start the question here without dealing the time. Yes, we know that very less number of days are left. Yes, we can say today is 24. Sit. Yes, so very few days are left here. So definitely it will help you. Okay. Definitely it will help you to get the 4 to 8 marks. All right. So let's start the topic here. The first one we have on a board here. Take a look here. So as I told you, this question is the latest question, we can say that, like जो पिछले 2-3 साल से काफी ट्रेंड में है. Okay, So just try to solve it, all of you. So we have a first question on a screen here. If alpha is a positive root of a equation p of x is given x square minus x minus 2 is equal to 0, then find the value of limit extending to a plus, no, it's alpha plus square root of 1 minus cos of px divided by x plus a, again I read a here, it's alpha minus 4 is equal to what? Yes, easy question, you all can do it. Yes, you all can do it. All right, take a look here. So we have a polynomial that is already given here, and remember it's a positive root. We need to take here the positive root. So first of all, what we need to do here, first of all, let's factorize. So p of x is equal to nothing but it is x square minus x minus 2 is equal to 0. That means 2 ones are. So it can be written as x minus 2 and x plus 1, which implies that like we have a 2 value of x, that means we have a plus 2 and minus 1, correct? But it is already given here alpha is positive root, so we have to assume 2 here, correct? Yes, it's a positive root of px, so we have to assume 2 here. आपको यहाँ पे 2 लेना है, positive number. So our question will become limit x tending to 2 positive, correct? 2 plus square root of 1 minus cos of px. What is the value of px? Look at here. It is nothing but x square minus x minus 2 divided by x plus alpha minus 4. So what is alpha here? Yes. Can you assume what will be the alpha we need to take here? That is 2 again. Yes. So we have x plus 2 minus 4. Or it can be written as what? Limit x tending to 2 plus square root of 1 minus cos of what we have here, x square minus x minus 2 whole divided by x minus 2. Done? Clear? Anything else? Now how do we solve here? 2 plus 4 minus, yes, 4 minus 4 0, 1 minus cos 0, 0 by 0 form we have actually. It is indeterminate form, correct? So how do we solve here? Any idea? Anyone know that? कैसे solve करें? 1 minus cos theta. Yes, अगर आपके पास 1 minus cos theta है, so what we can write it? Remember, like I have to just simply do the rough calculation like 1 minus cos theta. Cos theta can be written like 1 minus 2 sin square theta by 2. Something like that. Half angle use कर सकते हैं हम यहाँ पे 1 minus 1 plus 2 sin square theta by 2. Or it can be written like 2 sin square theta by 2 only. Clear? So we need to use this here. Now we have a limit x tending to 2 plus. Yes, obviously it's 0 by 0. Correct? We can use L hospital rule or we can say L L'Hopital, जो भी आप कहते हैं उसे. Yes, we can differentiate numerator and denominator separately here. But can we get the answer quickly? Like we have a 1 by 2 root of 1. Again, we will get indeterminate form here. Correct? That's why. So just apply half angle formula here. So inside the square root, what we get here, we will get 2 sine square, and in place of a theta, that is x square minus x minus 2 divided by what? X minus 2. Is it clear? Yes. What next? Limit x tending to 2 plus, yes, square root of 2 is constant. We have a sine of x square minus x minus 2 divided by x minus 2. What will be the next step? What will be the next step? Root 2 is the constant part. Limit x tending to 2 plus sine of, look at the factorization of x square minus x minus 2, that should be is nothing but x minus 2 and x plus 1, and at the denominator we have a x minus 2 here. Yes. Can we do the arrangement here? Just multiply by x plus 1 in numerator and x plus 1 in denominator. Correct? Just focus on this part here. Limit x minus 2 tending to 0, something like that. It will become what? Yes. It should be theta by 2. Exactly. ये theta by 2 होता है. Yes. It is theta by 2. Remember. It should be theta by 2. आपने थीटा बाई 2 को मिस किया हाफ एंगल फॉर्मूले में। ऑलराइट, सो नो वरी, आपको बस सिंपली यहां पे क्या करना है, डिवाइड बाई 2 भी करना होगा, and that part also, and here we will get one more 2 here. So this part is nothing but will become 1. So what we have here, if we theta like a limit x tending to 2 plus, we have a root 2 by 2 times, and x plus 1 will become what? 2 plus 1, that is 3 here. So 3 root 2 by 2 is the answer. Or if we simplify, that is nothing but 3 by root 2. Option C is the right answer. Clear? Yes, option C is the right answer for an answer. Can you note it down? Any doubt? Any confusion you can ask me. All clear? Okay, let me do the next part, the next one. Question number 2 here. Again, one of the easiest here. Limit as tending to 0, 2 times of square root of 3 sine of pi by 6 plus h minus cos of pi by 6 plus h whole divided by root 3 times h, then root 3 cos h minus sin h is equal to what? Can you do that, this question? Is that possible? How do we solve? Anyway, 2 is the constant value, just take outside. Take a look here. So can we write like 2 times limit h tending to 0, that is root 3 sine of pi by 6 plus h minus cos of pi by 6 plus h whole divided by, yes, whole divided by what we have, that is root 3 h root 3 cos h minus sin of h. Done? So just substitute the value here. 0, yes, root 3 sin 30, root 3 by 2 minus cos 30. Yes, what kind of, again at the denominator we have a 0 actually. Yes, again आपके पास एक indeterminate form है, so we have to convert it. So can you approach how do we solve here? Yes, कैसे solve करें? Anyone know that? Any idea? Simple, we can see that we have to just again do the arrangement here. Yes, just do the arrangement here. We need to simply do what? Divide by 2 and multiply by 2, correct? Like that here. And at the denominator as well. Yes, at the denominator as well here, we need to just do what? Divide by 2 and multiply by 2, like that here. So just write it down what we have here. 4 limit h tending to 0. Now root 3 by 2. Can we write like a cos pi by 6? Yes, cos 30, cos pi by 6. Then sine of pi by 6 plus h minus, yes, what we have here? 1 by 2 sine pi by 6 cos of pi by 6 plus h whole divided by, yes, 2 root 3. Again we have a constant 2 root 3, that is h as well. Now root 3 by 2 sine pi by 6 cos h minus cos pi by 6 sin h. Done? Now at the numerator, look at the formula, sin a cos b plus cos a sin b. So first of all, write down all the constant part here. We have a 4 by 2 root 3. Then we have a limit h tending to 0. Clear? So sin a minus b we have here, that is nothing but sine of pi by 6 plus h minus h, and at the denominator we have h time, again sin a cos b minus cos a sin b. So we have a sin a minus b, that is sine of pi by 6 minus h. Clear? So h gets cancelled out. What we have here, not h gets cancelled out, actually यहाँ पे h नहीं कैंसिल होगा. आपके पास a का वैल्यू क्या है? यस, a को रिप्लेस करना है आपको पाई बाई 6 प्लस एच से, yes, and आपका b कितना है पाई बाई 6 है. Now pi by 6 gets cancelled out, so we have a 4 by 2 root 3 limit h tending to 0 sine of h by h time sine of pi by 6 minus h. Clear? Now apply limit here. Yes, this portion will become what? 1 here. We have 4 by 2 root 3 into 1 by sine 30. Yes. What is sine 30 here? 1 by 2. Try to solve it. What will be the answer? Yes, you will get the answer. All of you, you may solve it and get the answer. Clear? Okay, take a look here. The next part, the next question. One of the important question we have here, question number 3. Let sk is given here, summation r equal to 1 to k here, tan inverse of 6 raised to power r divided by 2 raised to power 2r plus 1 plus 3 raised to power 2r plus 1. Then limit k tends to infinite sk is equal to what? Again, one of the easiest question we have here. Yes, आपने इस टाइप की क्वेश्चन सीक्वेंस में भी किया होगा, करेक्ट, बाइनोमियल में भी किया होगा, इस तरह का सम निकालने में. यस, कैसे अप्रोच करते थे, रिमेंबर? लाइक जो आपके न्यूमरेटर में होता था उसे डिफरेंस क्रिएट करते थे, रिमेंबर? जो भी आपका डिनोमिनेटर होता था उसे ऊपर क्रिएट करते थे, न्यूमरेटर में उसका डिफरेंस क्रिएट करते थे. यस और नो? ओके, ऑलराइट. सो वी हैव व्हाट? 6 raised to power r divided by 2 raised to the power 2r plus 1 plus 3 raised to power 2r plus 1 here. So इसे कैसे ब्रेक करें? ये 6 raised to power r को और कुछ मल्टीप्लाई या डिवाइड कर सकते हैं. एनीवन? यस, एनीवन? किसी टर्म से मल्टीप्लाई या डिवाइड करें. ऑलराइट. Okay, take a look here. Just write down 6 raised to power r divided by 2 raised to power 2r plus 1 plus 3 raised to power 2r plus 1. Okay, at the numerator we can write multiply by 1. Yes, अभी tan, ये जितना समेशन वाला पार्ट है tan वाला अभी हम लगाते हैं. फिलहाल के लिए अभी डिफरेंस क्रिएट करते हैं. और 1 कैन बी रिटन व्हाट? 1 को आप क्या लिख सकते हैं? Yes, 3 minus 2. Now 6 raised to power r just multiply, और 6 raised to power r को आप ब्रेक करके मल्टीप्लाई करें, लाइक 2 raised to power r into 3 raised to power r multiply by 3 minus 2 divided by 2 raised to power 2r plus 1 plus 3 raised to power 2r plus 1. Clear? Yes? Okay, just multiply inside it. So when first term multiply, what we have? 2 raised to power r into 3 raised to power r plus 1 minus, then what we have? 2 raised to power r plus 1 into 3 divided by 2 raised to power 2r plus 1 plus 3 raised to power 2r plus 1. Clear? Yes? Okay, what next? अब क्या करें? Next is look at the denominator. Yes, look at the denominator. We need to just make what? 3 by 2 here. So if we take 2 raised to the power 2r plus 1 common, so we get inside the bracket 3 by 2 raised to power r plus 1 minus 3 by 2 raised to power r, and which is divided by 1 plus 3 by 2 raised to power 2r plus 1, and outside the bracket we have a 2 raised to power 2r plus 1. Yes, at the numerator and denominator we just take a common 2 raised to power r plus 1 only. They will cancel out. So again, once we have write it down, it will become like a 3 by 2 raised to power r plus 1 minus 3 by 2 raised to power r. Now again it is 2r plus 1, so it can be written 1 plus 3 by 2 whole raised to power r plus 1 into 3 by 2 raised to power r. Now outside this we have a tan inverse. Is it? Yes, like sk is nothing but summation r equal to 1 to k, that is tan inverse, yes, tan inverse of 3 by 2 whole to the power r plus 1 minus 3 by 2 whole to the power r divided by 1 plus 3 by 2 whole to the power r plus 1 into 3 by 2 whole to the power r. It seems like a tan inverse of a minus b upon 1 plus ab. Just apply summation. Apply summation here. What it could be? Yes, at r equal to 1. So we have a tan inverse of 3 by 2 square minus tan inverse of 3 by 2. Now at r equal to 2, that is tan inverse of 3 by 2 whole cube minus tan inverse of 3 by 2 whole of square. Similarly, r equal to 3, that is tan inverse of 3 by 2 raised to power 4, and then here tan inverse of 3 by 2 whole cube, and so on. It will goes on and on. At r equal to k, remember, we have tan inverse of 3 by 2 raised to the power k plus 1 minus tan inverse of 3 by 2 raised to the power k. Now, we need to add, because we have a summation. Once we add all this stuff, yes, look at here. Which term will cancel out here? Yes, look at the diagonally. Diagonally पे आपको देखना है. This will get cancel out like that. Yes. So what we have here? This term will left and one constant. So that will be like sk is nothing but tan inverse of 3 by 2 raised to the power k plus 1 minus tan inverse of 3 by 2. Clear? Now let's apply limit. K tends to infinity. Tan inverse of 3 by 2 raised to the power k plus 1 minus tan inverse of 3 by 2. What will be the answer? Yes, the second term is constant here, which is free from k here. Yes, the first one will become what? When k plus 1 infinity, that means it should be like a tan inverse infinite minus tan inverse 3 by 2, or it can be written what? Tan inverse infinity is pi by 2 minus tan inverse of 3 by 2. Now what is pi by 2 minus tan inverse theta? Cot inverse theta. Cot inverse 3 by 2 will be the answer. Okay. All right. Zia official. Yes, just note it down. Kindly note it down. Very easy and very simple. One of the easiest question we have here. Okay, let's take a look here. The next part, the next question. Yes, यहाँ पे हमारा आंसर होता है cot inverse 3 by 2. Okay, obviously option A is the answer. Clear? Take a look here. The next one. Yes, question number 4. Take a look here. What we have here? All right. Yes, take a look here. We have a function, let alpha belongs to a real number such that function fx is equal to is given here. Yes, whole function is defined here where x does not equal to 0, and then alpha, that value of function is alpha here. It is continuous at x equal to 0, where look at here. Yes, fractional x is nothing but x minus gent of x. Yes, it is the greatest integer, remember. So it is continuous. It is continuous. Clear? So if it is continuous, so what we need to calculate here? Left hand limit and right hand limit. Yes, and the value function, they all must be equal. Is it? They all must be equal. So can you do that here? Yes, can you do it yourself, this question? Anyone? How do we solve? Anyone? Any idea? कैसे सॉल्व करें? Yes. Like first of all, we need to calculate what? Right hand limit. It will be nothing but limit x tending to 0 plus. Okay, at 0 plus and 0 minus, they both will be same here. But यहाँ पे आपको define करना होगा किसे? Fractional of x को, जो कि given है x minus mod of x here. Now, what it will be if we have a value like a more than 0 here, 0 plus. Yes, at 0 plus, like 0 point something. Yes, 0 point something पे ये जो आपका box x है ये क्या हो जाएगा? It will become 0. So fractional of x is nothing but it's x. Is it? Exactly. So can we write it is nothing but cos inverse of 1 minus x square sine inverse of 1 minus x divided by x minus x cube? Yes. Now substitute at 0. At 0. What kind of a form it is? Anyone? How do we solve? At cos inverse 1 minus x square sine inverse of 1 minus x upon x minus x cube. कैसे solve करें? Just try to simplify here. Limit x tending to 0 plus. It is cos inverse of 1 minus x square sine inverse of 1 minus x divided by, just take an x common, we have a 1 minus x square. Okay. कैसे solve करें अभी? Any idea? Anyone? How could we find here? Cos inverse of 1 minus x square, then we have a sine inverse as well. Yes, काफी सारे inverse हैं. Anyone? कैसे अप्रोच करें? कैसे सॉल्व करें? लिमिट x टेंडिंग टू 0 प्लस. यस, cos इनवर्स ऑफ 1 माइनस x स्क्वेयर बाई x टाइम 1 माइनस x 1 प्लस x and at the numerator we have a sine inverse of 1 minus x. Correct? Let's apply limit here. लिमिट को अप्लाई करते हैं. Where? कितने पोर्शन में? Sine inverse of 1 minus x by 1 minus x will be what? It will be 1 at x tending to like a pi by 2 here. So we have nothing but limit x tending to 0 plus. That should be like a cos inverse of a 1 minus x square by x minus x cube. This time we have a 0 by 0 form. Apply L hospital. Minus 1 by root over 1 minus x square, that is 1 minus x square of whole square. And at the denominator what we have here? 1 minus 3x square. Let's apply the limit here. You will get what? RHL. Yes, at 0 plus. RHL at 0 plus. What we get? Anyone know that? Any idea? क्या कोई आइडिया है कैसे इसे सॉल्व करें? एनी वन? यस, एनी आइडिया? ऑल ऑफ यू. cos inverse 1 minus x square sin inverse of 1 minus x upon 1 minus x, then 1 plus x and x है वहां पे. क्या करें, कैसे सॉल्व करें? एनी आइडिया? कैसे सॉल्व करेंगे? ओके, एक काम करते हैं यहां पे, साइन इनवर्स ऑफ 1 माइनस एक्स में लिमिट को अप्लाई कर लेते हैं. इज इट? यस, साइन इनवर्स 1 माइनस एक्स में लिमिट को अप्लाई करते हैं, क्योंकि 1 माइनस एक्स अपॉन 1 माइनस एक्स तो 1 तो होना नहीं है. यस, तो आप क्या करते हैं, साइन इनवर्स ऑफ 1 माइनस एक्स में लिमिट को अप्लाई कर लेते हैं. इतना ही करते हैं. यहां पे we get what? Sin inverse 1, that is pi by 2. Just take outside the bracket. Now we have a limit x tending to 0 plus cos inverse of 1 minus x square by x times 1 minus x and 1 plus x. Or it can be written like pi by 2 limit x tending to 0 plus. It should be like a cos inverse of 1 minus x square by x minus x cube. What next? What will be the next step? Yes, अगला स्टेप क्या हो सकता है आपका? अप्लाई लिमिट 0 plus 0 by 0 here. Can we apply L hospital rule? क्या उसे हम अप्लाई करें? Differentiation of a cos inverse theta, it is nothing but 1 by 2 times root over, yes, minus 1 by 2 times root over 1 minus x square, and at the denominator we have a 1 minus 3x square, correct? This portion we will get here. Now let's substitute the value. Kindly substitute the value here. What we get? Any idea? Pi by 2 as it is, minus 1 by 2 we have here. Now this should be what? 0 by 0. Okay, we need to just expand it. A plus b, a minus b form. We will get pi by root 2 will be the final list. Yes, pi by root 2. Take that. Clear? That is our RHL. Yes, that is our RHL. Now next is what? Next we need to calculate what? Left hand limit. So again आपको properly define करना होगा किसे? Yes, fractional of x को. Exactly, fractional of x will be what? So this time it will be nothing but we have cos inverse of 1 minus x plus 1 whole of square, and that should be sine inverse of 1 minus x plus 1 and whole thing divided by x plus 1 minus x plus 1 whole of cube. Clear? Okay. Now just expand this portion here, 1 minus x plus 1 whole square here. So it can be nothing but what we have here, left hand limit, or we can say here limit extending to 0 minus as well. So we have a limit extending to 0 minus, it is nothing but cos inverse of minus of x square minus 2x, and that should be nothing but sine inverse of minus x in next bracket divided by, we have to take x plus 1 common, 1 minus x plus 1 is square. Just apply the limit in this portion. Yes, 0, cos 0, 0, that means what? It should be nothing but pi by 2. Again, we have to write down limit extending to 0 minus. Just write it down pi by 2 here. And we have a sine inverse of minus x divided by x plus 1 and minus x square minus 2x. Clear? Or it can be written what? Pi by 2 limit extending to 0 minus sine inverse of x. Yes, we have a minus sign as well here. Sine inverse of x upon x divided by 1 by, yes, just factorize this term here, x plus 2 and x plus 1. Why x plus 2 and x plus 1? Once we take the minus common, it will become positive. Now apply limit. This will be 1 here. Clear? So it should be like a pi by 2 and half. It is nothing but pi by 4. So clearly we can say that, look at the left hand limit and right hand limit, pi by root 2 and pi by 4. They both are not equal actually. They both are not equal. So we can say that which option is true here? Yes, option is the right answer. No such value of alpha exists here. Okay, moving forward, question number 5. Let's take a look at question number 5. The value of a limit theta tends to 0 tan of pi cos square theta divided by sine of 2 pi sin square theta is equal to what? Can you try, all of you? I'm just waiting. आप try कर सकते हैं. Yes, आप solve करें, try करें. Which option is true? Take your time, all of you. Okay, Aman. All right. Yes, yes, take your time. क्या आंसर आएगा? Anyone? All right. So can we write like a limit theta tends to 0 tan of pi cos square theta divided by sine 2 pi sin square theta. Theta tends to 0, cos 0 1, tan pi. Yes, 0 at the denominator, again 0. Indeterminate form we have here. Any idea? Can we write like a limit theta tends to 0 tan of pi cos square theta? Yes, pi cos square theta. Cos square theta को आप लिख सकते हैं 1 minus sin square theta, or it can be written like pi minus pi sin square theta divided by sine of 2 pi sin square theta. Focus at the numerator again. Tan 180 minus theta minus tan theta. So it can be written what? Limit theta tends to 0 minus 1 time tan pi sin square theta divided by sine 2 pi sin square theta. Now what next? What next? Again, indeterminate form. Can we adjust? Like we know that sine theta by theta is nothing but 1. Correct? When theta tends to 0. So can we write like a minus 1 time limit theta tends to 0. We have a tan pi sin square theta and divided by which number we have here? That is sine of 2 pi sin square theta. So we have to just adjust again. फिर से adjust करते हैं यहाँ पे. Just simply multiply pi sin theta at the numerator and pi sin theta at the denominator, like that. Yes. Again at the numerator we have a pi sin theta. Can we multiply 2 at numerator and denominator again here? Yes. So focus on this part here. What we have here. Yes. They both is nothing but 1. Once the theta approaches to 0 here. So we will get tan theta by theta is 1 here. Yes. And sin theta by theta, again we have a 1. So we will get finally minus 1 by 2 is the answer. Clear? Just note it down. Minus 1 by 2 is the right answer for an answer. Noted it done? Alright. Moving forward. What we have? Question number 6. Alright, let a function f such that r to r be defined as fx is given here sin x minus a raised to power x. If x like less than equal to 0, then we have a plus, look at here, chain of minus x. If 0, like x is between 0 and 1 here, more than 0 but less than 1, then 2x minus b if x is more than equal to 1 here, where yes, box x is nothing but greatest integer which is less than or equal to x. If f is continuous, then find a plus b here. So you can try this question. Okay, you can take as an homework here. आप इस क्वेश्चन को होमवर्क की तरह कर सकते हैं. Yes, it is continuous. Remember. Okay. Yes, you have to check at x equal to 0 and at x equal to 1 as well here. You can do it yourself here. Okay, and just write your answer in a chat box. आपको खुद से इस क्वेश्चन को करना है और अपने आंसर को कमेंट करना है. Correct? Which option is true here? Like A, B, C, D. Don't forget to comment your answer, all of you. Yes, you can take as an homework here. Alright, focus on the next here. Question number 7. Yes, take a look here. Very important question we have here. Let f such that r to r, fx is defined here. X cube by 1 minus cos 2x whole square log base e 1 plus 2x e raised to power minus 2x divided by 1 minus x e raised to power minus x whole of square, where x does not equal to 0. Is it? Yes, and f is continuous at x equal to 0. Look at the value of a function. Value of function is given here. At x equal to 0, we have a value function is 0 here. Correct? It's alpha. So what will be the value of alpha here? Can you try? Yes, it is continuous. So if it is continuous, x does not equal to 0 here. So in both the case, left hand limit and right hand limit, we have to write it down the same thing here because the value function is given. So कैसे approach करें इसे? Like we have a limit x tending to 0. Either 0 plus and 0 minus, both will be 0. Both will be equal here. So can we write like how we can solve here? X cube by 1 minus cos 2x. Can we apply cos 2x formula here, like 1 minus cos 2x is what? Yes, 1 minus 2 sin square x, that half angle formula, or it can be nothing but what? 2 sin square x. And at the denominator we have a square, so it can be written as what? X cube by 4 sin square x. Yes, like that. X cube by 4 sin square x, like that. And again at the box what we have? Log of 1 plus 2x e raised to power minus 2x divided by 1 minus x into e raised to power minus x whole of square. How do we solve? Any idea? Anyone? कैसे solve करें इसे? Anyone? Yes, which is equal to alpha, or it can be written what? Limit x tending to 0, x times x raised to power 3 by 4 times sin square x, or we have to break like a 4 times sin x cube is nothing but x cube को आप break कर सकते हैं यहाँ पे, like something we can say x square into x. Yes, or we can say like a sin square by x is nothing but 1 here. So at the end, like we have, once we open the log m into n, log m minus log n, so it can be written as 1 by 4x 2x e raised to power minus 2x plus 2x e raised to power minus x, which is equal to alpha, or it can be written as what? Once we take x common, 1 by 4x times x, that is, yes, we can take 2 as well common, e raised to power minus 2x plus e raised to power minus x, which is equal to alpha. X gets cancel out, that is 1 by 4 times 2, apply limit, that is 0, so we have 1 plus 1, that is alpha, or it can be written as 4 by 4. Yes, alpha is 1 here. Done. Option A is the right answer. Alpha is 1 here. Okay, take a look here. The next one, the next part. Take a look here. The next one, the next part. Yes, we have a question number 8 here. Let we have a function r2 defining a lambda time modulus of x square minus 5x plus 6 divided by mu time 5x minus x square minus 6, where x is less than 2. E raised to power tan of x minus 2 by x minus, yes, greatest integer of x, that is x more than 2, and at x equal to 2 we have a value mu here. So again it is continuous. At x equal to 2, then find lambda plus mu. So same pattern we have to use, like a same question. It is similar to question number 6 here. Okay, जैसा आपने question number 6 को किया है. So we need to just define this portion here, x square minus 5x plus 6. yes, आप इसका critical value भी निकाल सकते हैं. x पे value x equal to 2 पे आपको function भी check करना होगा, correct, and define it and find the value. Yes, lambda plus mu आपको solve करना है and write your answer in a chat box, all of you. Clear? All right, let's take a look here. Moving forward, we have a next question, question number 9. The value of a limit extending to 0, x by, again, yes, it's like 1 minus sin x whole raised to power 1 by 8 minus 1 plus sin x whole raised to power 1 by 8 is equal to, again, how do we solve? Any idea? एनीवन? कैसे सॉल्व करें इस क्वेश्चन को? ओके, ऑल राइट, टेक अ लुक हियर, कैसे सॉल्व करते हैं? सो just substitute the value here. If sin 0 is 0, so again we have a 1 minus 1. It's nothing but 0 by 0 form. क्या आप इस यहां पे L hospital rule लगा सकते हैं in this portion 0 by 0 में? Yes or no? We can see that like limit x tending to 0, x by आपके पास है yes x by 1 minus sin x power 1 by 8 minus 1 plus sin x power 1 by 8. This is our question here. So how do we solve here? Let's rationalize. Try to rationalize. We have to rationalize it, correct? Yes, just do it. Write down limit x tending to 0, x time divided by 1 minus sin x raised to power 1 by 8 minus 1 plus sin x raised to power 1 by 8. So how do we solve here? We need to simply multiply and divide in numerator and denominator 1 minus sin x raised to power what? 1 by 8 plus 1 plus sin x raised to the power 1 by 8 whole divided by 1 minus sin x raised to the power 1 by 8 and plus 1 plus sin x raised to the power 1 by 8. Done? Limit x tending to 0, x time 1 minus sin x raised to the power 1 by 8 into, not into, we have a plus sign, 1 plus sin x raised to power 1 by 8, and at the denominator what we get here? At the denominator a plus b, a minus b. Yes, a plus b and a minus b. A square minus b square. Yes, 1 by 4, 1 minus sin x raised to the power 1 by 4 minus 1 plus sin x raised to the power 1 by 4. Clear? Now at the numerator term, let's apply the limit here, x tending to 0, this portion. आप इतने part में limit को apply कर ले. Yes, sin 0, like we have a 1 plus 1, that is 2 here. So 2 is the constant here, 2 left here. So what we have right now, limit x tending to 0, we have x by 1 minus sin x raised to the power 1 by 4 minus 1 plus sin x raised to the power 1 by 4. What will be the next step? अब क्या करें? Again rationalize the denominator. Is it? So फिर से rationalize करते हैं denominator को. We get what? 2 time limit x tending to 0, x time. What we will get here at the denominator? 1 minus sin x raised to the power 1 by 4 plus 1 plus sin x raised to power 1 by 4. और डिनोमिनेटर में क्या हो जाएगा? अगेन सेम फॉर्मूला a plus b, a minus b आपको अप्लाई करना होगा. Yes, what we get here? 2 by 4, 1 by root 2. Exactly. 1 minus sin x raised to the power 1 by 2 minus 1 plus sin x raised to the power 1 by 2. अगेन आप इतने पोर्शन में क्या अप्लाई करें? लिमिट को अप्लाई करें. So we will get another 2. So that means what left? 4 time limit x tending to 0, x by 1 minus sin x raised to the power 1 by 2 minus 1 plus sin x raised to the power 1 by 2. अगेन लास्ट टाइम एक बार फिर से रैशनलाइज करना होगा. यस, लास्ट टाइम एक बार फिर से रैशनलाइज करेंगे. सो व्हाट वी विल गेट हियर? 8 टाइम x लिमिट x टेंडिंग टू 0. सो आपकी जो पावर थे वो 1 by 2 ना होके बस 1 पावर रिमेन होगा. दैट मीन्स 1 माइनस साइन x माइनस 1 प्लस साइन x, और इट कैन बी रिटन व्हाट? 8 टाइम. Yes, At the denominator, what left? Limit x tending to 0, x by minus 2 sin x, or we can say 8 by minus 2, limit x tending to 0, x by sin x, and this will be nothing but 1. So we have a final answer minus 4. Done. Minus 4 will be the final answer. Kindly note it down, each and everyone. Clear? Noted it down. Take a look here. The next one, question number 10. Limit extending to 2 here. Summation n equal to 1 to 9 x by n time n plus 1 x square plus 2 time n 2n plus 1 x plus 4 is equal to what here? So again ये बाइनोमियल टाइप का क्वेश्चन, आपको पता है न्यूमरेटर में आपको क्या करना होता है, डिफरेंस क्रिएट करना होता है, समथिंग लाइक दैट. सो सबसे पहले आप एक्सटेंडिंग टू 2 कर लेते हैं यहाँ पे. ओके, लिमिट को अप्लाई करके जरा देखते हैं, फिर बाद में समेशन को अप्लाई कर लेंगे लाइक दैट. सो वी विल गेट 2 बाई n plus 1, that is 4, plus again it should be 2 2s are 4, 2n plus 1 and plus 4, or it can be written as 2 by, yes, n square, that is 4n square, plus how many n are there? 4n, 8n, that means total 12n, plus constant, yes, constant. Try to find out the constant here. Only one constant we have here, that is 4. Yes, how many constants are there? Only 4. Or what it can be written? 2 by 4 common, we have n square plus 3n plus 1, like that. Is it? Yes. यही बच रहा है, or we need to just do this simple simplification first. Let me do one more time. So सबसे पहले हमने लिमिट को 2 अप्लाई किया, then we have a 4 time n plus 1 plus 4 time 2n plus 1 plus 4, or we can cancel out 2 as well here, or it can be written what? 2 by 4n square plus 4n plus 8n plus 4 and plus 4, or it can be written as 2 by 4n square plus 12n plus 8, or it can be written as like a 2 by 4 common at the denominator, what we have, n square plus 3n plus 4, actually, yes, plus 4, we were missing that thing. Okay, अभी क्या करें? 1 by 2, yes, 1 by 2 is nothing but constant here. So can we just do what? We can just factorize the denominator, like n square plus 3n plus 4. 4 ones are 4 plus 3n square plus 4, or what it can be written here? क्या कर सकते हैं आप? Any idea? Anyone? It can be written as like a 1 by n plus 1 minus n by n 1 by n plus 2, or if you apply this summation n equal to 1 to 9, what it can be? Yes, half is common already here. It can be 1 by n plus 1 minus 1 by n plus 2, and once we substitute the value from 1 to 9, yes, 1 to 9, अगर आप 1 पुट करें So it can be 1 by 2 minus 1 by 3. Then 2 put kare. So that should be like 1 by 3 minus 1 by 4 and so on. Successive term will cancel out here like that. So we have only left 1 by 2 minus 1 by 11. Clear? 1 by 2 and 1 by first and last term. Solve it. 9 by 22. 2s are 9 by 44 will be the answer. Yeah. Just note it down. Clear? Okay. All right. Take a look here. The next part, the next question. Question number 11 we have here. If limit extending to infinity is square root of x square minus x plus 1 minus ax is equal to b, then find the ordered pair of AB here. को A और B का वैल्यू निकालना है, ordered pair, limit extending to infinity here, and the value which is equal to B, remember. So how do we solve here? We need to find A and B as well here. Limit already exists, remember. So we have limit extending to infinite, square root of x square minus x plus 1 and minus ax, which is equal to B, remember, which is equal to B here. So what will be the answer? How do we solve here? Like if we substitute x is infinity, indeterminate form, infinity minus infinity form, indeterminate. Anyone? कैसे solve करें? All right. Just do it what? Just do it what? Just rationalize here. Like a square root, we have a square root value here, x square minus x plus 1 plus ax at the numerator, and at the denominator as well we have a x square minus x plus 1 plus ax. Clear? Now look at the numerator, a plus b, a minus b, just apply a square minus b square. So we have a x square minus x plus 1 and minus a square x square, and at the denominator what we have, square root of x square minus x plus 1 plus ax, and here we have a limit x tending to infinity here. Now again, can we write like at the numerator, limit x tending to infinite, we have x square common, that is 1 minus a square, then x square, and then we have a minus x plus 1, and at the denominator we have square root of x square minus x plus 1 plus ax. Remember, this value is always equal to b here. Okay. All right. Now focus on a board here. Motivation. Give me the motivation. Okay. Only few days are left here. Only few days. 2 से 4 दिन की बात है. Clear? Yes. धीरे धीरे पढ़ाई करें. Like 2-3 घंटे पढ़े, फिर उसके बाद थोड़ा ब्रेक ले, फिर उसके बाद continue like that. Okay, Navya? All right. Don't confuse. So take a look here. Yes, be fresh. इससे क्या होगा, आपका कंटिन्यूटी भी बना रहेगा. ओके, ऑलराइट. कभी भी ऐसा कुछ फील हो तो आप वहीं पे स्टॉप करें, थोड़ा फ्रेश हो, जो भी अच्छा लगे आपको, चाय कॉफी वो पी सकते हैं, उसके बाद फिर से स्टडी करें. ऑलराइट, टेक अ लुक हियर. सो लिमिट ऑलरेडी एग्जिस्ट हियर. So if limit is already exists here, like x square portion, so that portion must be 0. ये portion 0 होगा. क्यों 0 होगा? Yes, we have a single variable here. We know that like if we have a limit approaches to infinity here, like 1 by x के term में आपको बनाना होता है. It will only possible if the first term will be 0. Understood or not? Like आपको क्या करना होता है, जब भी लिमिट x टेंडिंग्स टू इंफिनिटी अप्रोच करता है तो आपको कौन से टर्म बनाने होते हैं, 1 by x, करेक्ट? सो दैट इट विल बिकम 0 हियर, टेंड्स टू 0 हियर. सो इट विल ओनली पॉसिबल इफ द फर्स्ट टर्म विल 0. Yes, or if 1 minus a square is 0 here, which implies that a is nothing but plus minus 1. Something like that. Yes, a is nothing but plus 1, we need to assume here. I know which option we have a plus 1 value here. Option A and B. Like that. Now, in remaining part, what we need to do here, take x common. minus 1 by x all right. In the remaining part, we have to take x common. So we have minus 1 plus 1 by x divided by, yes, if we take x common, what we have here, if we take x common inside the bracket, we have 1 minus 1 by x plus 1 by x square plus a, which is equal to b. Is it clear? Now, this will cancel out. And what we have here, once we apply the limit extending to infinity, we have a minus 1 by 1 plus a is equal to b. Yes. So why we cannot assume minus 1? If we take a is minus 1 as well, so here at the denominator again it will vanish here. Yes, indeterminate form again it will generate here. That's why we have to assume a is positive. Now, minus 1 by 2 is nothing but b here. So we have an ordered pair. A comma B. A comma B is nothing but 1 comma minus 1 by 2. Just note it down. All of you. Clear? Easy? Yes. We will get both the value here actually. 1 and minus 1 both here. If we substitute minus 1, you cannot get the value here. Okay, focus on the next here, the next part. Yes, question number 12. Again, one more easiest question. You can do it yourself here. आप इसे homework की तरह assume कर सकते हैं. This is the third question taken as homework here. I just give you one hint here. We have a sin square theta at the numerator. Just try to convert into cos term. Like we can write it down here is nothing but what? In cos term, like we know the formula. Cos 2 theta is nothing but 1 minus 2 sin square theta. Or what will be the 2 sin square theta? Like what will be the sin square theta only? Like if we write down 2 sin square theta, it will be nothing but 1 minus cos 2 theta, and sin square theta will be what? 1 minus cos 2 theta by 2. So just try to convert it. So it will become what here? We have a limit extending to 0. 1 minus cos 2 pi cos raised to the power 4x whole divided by 2 times x raised to the power 4. Now try to adjust, you will get the answer here. One more hint, एक और hint दे सकता हूं मैं आपको. आप इस cos थीटा को ब्रेक कर सकते हैं cos 180 माइनस थीटा में. Okay, all right, like limit extending to 0, 1 minus cos 2 pi minus 2 pi cos raised to the power 4x. Clear? Exactly. And divided by which term? 2 times x raised to the power 4 here. And what is cos 180 minus theta? Like 360 minus theta, something like that. You can apply. Very easy question now. Yes, आप बस adjustment करें, you will get the answer. Clear? Yes. इसका आंसर I think 4 pi square होगा. So easy. आप काफी आसानी से इसे solve करके comment box में अपना आंसर लिखिए. Clear? All of you. Yes. Yes. आप सभी के लिए है इस क्वेश्चन को solve करना है. Okay? Yes, you all can do it. काफी easy question है. All right. Take a look here. The next part, the next question. What we have here. Okay. All right. If the function 1 by x ln 1 plus x by a by 1 minus x by b is less than 0 when x is less than 0 and x is equal to 0 is k here, and another function we have a cos square x minus sin square x minus 1 divided by root over x square plus 1 minus 1 when x is more than 0 is continuous at x equal to 0, then find the value of 1 by a plus 1 by b plus 4 by k. Any idea? Anyone? How do we solve here? Yes, let's find it out. RHL, left hand limit, that is limit x tending to 0 minus or 0 plus. Yes, कुछ भी निकाल सकते हैं हम पहले, no worry. So let's find out 0 plus, that is right hand limit here. So what we have here, cos square x minus sin square x minus 1 divided by root over x square plus 1 minus 1 here. So 0, cos 0, 1, 1 minus 1, 0 by, again, 1 minus 1. It is 0 by 0 form. L हॉस्पिटल लगाते हैं तो काफी लेंदी जाता है. Yes. So क्या करें? Try to solve it. क्या आप इसे ऐसे लिख सकते हैं? Limit x tending to 0 plus cos square x. Yes. And taken again like in a first and last term. First and last term को आप कैसे लिख सकते हैं? Cos square x minus 1, then minus sin square x. The denominator is same here. It is x square plus 1 minus 1. Or we can say cos square minus 1 is nothing but, it's nothing but minus sin square x. And again we have a minus sin square x divided by root over x square plus 1 minus 1. Or we can say it is limit x tending to 0 plus minus 2 sin square x by root over x square plus 1 minus 1. What next? Rationalization of the denominator. क्या हम डिनोमिनेटर का रैशनलाइजेशन कर सकते हैं? Yes. If we multiply and divide by root over x square plus 1 minus 1 in numerator and denominator, what we get? What we get? Any idea? Yes, it should be plus here. A root over x square plus 1 plus 1. So at the numerator, what we have here should be like a limit x tending to, what we have, 0 plus minus 2 sin square x into root over x square plus 1 divided by x square. Now focus on this part here, this whole part. It will become 1 here. So we have what? Minus 2 times multiply by 2, that is 4. Time to find out left hand limit. Yes, like a limit x tending to 0 minus, that should be nothing but 1 by x log of, that means ln base here, 1 plus x by a divided by 1 minus x by b. Is it? Or it can be written like a limit x tending to 0 minus, it can be written like a log m by n, log m minus log n, log of 1 plus x by a by x minus limit x tending to 0 minus, that should be log of 1 minus x by b by x. Simply just adjust it. Yes, लिमिट में लॉग वाला फॉर्मूला आप लोगों को पता है, काफी इजी होता है. वी हैव टू जस्ट एडजस्ट हियर बाय a multiply by a, and here we have a coefficient is minus here, so once we just put down plus sign it will be become minus now. So it should be like again divide by b and multiply by b here. So what we get here, it will nothing but 1 by a and 1 by b here. Yes. So finally we have left hand limit and right hand limit, and value function is k here, like LHS and RHS, that should be like a 4 equal to 1 by a plus 1 by b, and which is equal to k here. So what will be the value of 1 by a plus 1 by b plus 4 by k? You have to find it out, final answer. Okay, आपको फाइनल आंसर फाइंड करना है और यस चैट बॉक्स में कमेंट करना है. रिमेंबर, डोंट फॉरगेट टू कमेंट योर आंसर. आपको अपना आंसर कमेंट करना है. रिमेंबर, all right, clear, noted and done. Okay, take a look here. The next part, the next question, question number 14 we have here. Yes, काफी इंपॉर्टेंट क्वेश्चन है. एक बार फिर से आपके सामने we have a alpha and beta both are given and both are the root of the equation ax square plus bx minus 4. Then find the order pair a comma b here. Yes, so focus on alpha first here. Alpha है क्या आपका, लिमिट एक्सटेंडिंग टू पाई बाई 4 tan cube x minus of tan x divided by cos of x plus pi by 4 here. Yes, just apply limit here. 1 minus 1 0 by pi by 4 plus pi by 4 90 0. It is again we have a 0 by 0 form. So how do we solve here? इनडिटरमिनेंट फॉर्म है तो क्या आप यहाँ पे लॉपिटल लगा सकते हैं? यस, वो भी अप्लाई कर सकते हैं. अदरवाइज आप कोई और दूसरा फॉर्म भी यूज कर सकते हैं, लाइक tan x को कॉमन ले सकते हैं. वी हैव अ tan स्क्वायर प्लस माइनस 1, देन वी हैव अ tan x माइनस 1 tan x प्लस 1. एग्जैक्टली उससे भी आंसर आएगा आपका. यस, उससे भी आपका आंसर आएगा, डोंट वरी. अदरवाइज जस्ट अप्लाई एल हॉस्पिटल, जो भी आप इसे कहते हैं, एल हॉस्पिटल हियर. सो tan क्यूब x is nothing but 3 tan square x into sec square x minus another sec square x divided by cos x minus times sine of x plus pi by 4. Let's apply 1. Yes, we have a 3 time, just apply the limit here. We have 3 time tan pi by 4, that is 1. Then we have a sec root 2 pi by 4, that means square 2 minus 2, like that, whole divided by 1 and minus 1 it will be. Try to solve it. 3 to the 6 minus 2, that is 4. Minus 4 is the value of alpha. Clear? Minus 4 is the value of alpha here. Now time to solve beta. All right, it's time to solve beta here. So beta क्या है आपका, लिमिट एक्सटेंडिंग टू 0 cos x raised to the power cot x. Supply cos 0 1, cot 0 infinite, 1 raised to the power infinite form. So if we have a 1 raised to power infinite, how do we solve? Any idea? Anyone? Try to solve it. Anyone? कैसे सॉल्व करें? Beta is nothing but e raised to the power limit extending to 0 cot x is power पहले लिखते हैं, then function minus 1 cos x minus 1. Clear? Or it can be written like e raised to the power limit extending to 0 cot को आप 1 by tan लिख सकते हैं. So we have a cos x, or if we have a cos x minus 1 by tan of x. Clear? Or we can say that e raised to power limit extending to 0. If we take minus 1 common, we can say cos x minus 1 को आप लिख सकते हैं 1 minus cos x and by tan x is there. Let me adjust first here. Like आप यहाँ पे x से multiply और divide कर सकते हैं, something like that. Okay, now what is like a tan x by x? Once the limit approaches to 0 here, it will be, the value is nothing but 1, correct? And we have a 1 minus cos x by x as well here, so it is 0. So we have a e raised to power 0 actually. Beta is nothing but 1. So alpha and beta are the root of the equation ax square plus bx minus 4. That means what? Yes. Just substitute the value alpha and beta. First we need to substitute what? X equal to minus 4 because it's alpha here. So we get what? 16a minus 4b minus 4 is equal to 0. That is equation number 1. And once we substitute beta, so what we get here? A plus b minus 4 equal to 0. That is second equation. Now try to solve these two here. You will get a and b. Yes, what we will get? A and B. A and B is nothing but 1 comma 3. Clear? Clear? Okay, let's take a look here. The next one, question number 15 here. Limit extending to pi by 2 tan square x multiply by 2 sin square x plus 3 sin x plus 4 whole raised to power 1 by 2 minus sin square x plus 6 sin x plus 2 whole raised to power 1 by 2 is equal to what? Focus on a limit part here. Yes, if you apply 10 pi by 2 infinite. Okay, and infinite minus infinite, again it is indeterminate form, we have to remove it. How do we solve here? Any idea? Like write down limit extending to pi by 2 tan square x as it is. So just try to rationalize this portion only which is inside the bracket. आपको बस इतना portion को rationalize करना है. Yes, if we rationalize like a 2 sin square x plus 3 sin x plus 4 whole raised to power 1 by 2 plus sin square x plus 6 sin x plus 2 whole raised to power 1 by 2. Yes, इस portion से आपको ऊपर नीचे multiply करना होगा numerator और denominator में. What we get at the numerator? Yes, a square minus b square portion आपको मिलने वाला है. Like we have a 2 sin square x plus 3 sin x plus 4 whole raised to power 1 by 2 minus sin square x plus 6 sin x plus 2 whole raised to power 1 by 2. Correct? Once we multiply at the numerator and denominator, like we have a 2 sin square x plus 3 sin x plus 4 whole raised to power 1 by 2 plus what we have? Sin square x plus 6 sin x plus 2 whole raised to power 1 by 2. Okay, so what left? Again आपको इसी सेम पोर्शन से यहाँ पे मल्टीप्लाई करना होगा. Is it? So at the numerator we have a minus b, a plus b, that is what? A minus b plus b, a square minus b square. So limit extending to pi by 2 tan square x as it is, and inside the bracket what left here? 2 sin square x minus sin square x. So we have a sin square x plus 3 sin x minus 6 sin x, that should be minus 3 sin x plus 4 minus 2, that should be plus 2. And at the denominator, what we need to do here at the denominator, let's apply limit pi by 2, 2 plus 3 plus 4, 9 raised to power 1 by 2, 9 raised to power 1 by 2, that is 3 into, again its plus sign is there, 1 plus 6 plus 2, that is 9. So again we have a 3, so 3 plus 3 is 6 here. So 1 by 6 is constant. We have a limit extending to pi by 2. Tan square x. Tan square x is nothing but sin by cos, correct? And we have a sin square x minus 3 sin x plus 2. It is quadratic in sin x. 2 ones are 2, correct? Or can we write like 1 minus sin x and 2 minus sin x, something like that? One minus sin x and 2 minus sin x. Okay, I have to rewrite again here. We have a 1 by 6, limit extending to pi by 2, sin square x by cos square x, and we have 1 minus sin x, 2 minus sin x. This is the portion left here. Okay, focus on denominator term, cos square x. Cos square x is nothing but 1 minus sin square x, or it can be written as 1 plus sin x, 1 minus sin x. So what left right now? 1 by 6, limit extending to pi by 2. We have sin square x, 1 minus sin x, 2 minus sin x, and at the denominator we have 1 minus sin x, 1 plus sin x. So 1 minus sin x will be cancelled out. So at the last we have 1 by 6 limit extending to pi by 2. Sin square x times 2 minus sin x divided by 1 plus sin of x. Let's apply limit this time, pi by 2. Take that. Yes, pi by 2. Sine 91. 2 minus, at the numerator we have a 2 minus 1 by 2 here. That should be nothing but 1 by 12 will be the final answer. Just note it down. Time to do the question number 16 here. Let's take a look here, all of you. How do we solve? One of the easiest, we can say that. काफी आसान क्वेश्चन है, काफी इजी क्वेश्चन है. Yes, student. Just take a look here. Take a look here. Limit extending to 1 by root 2. Yes, 1 by root 2, sin 45. Again, 45 1 by root 2 minus 1 by root 2, we get 0 at the numerator. And again, 1 minus x is 1 by root 2, 45, 1 minus 1. It is 0 by 0 form. So can we apply L hospital like a 1 sine, like a cos of cos inverse of x, then again minus 1 by root over 1 minus x square and so on. काफी ज्यादा रूट होगा, फिर से डिनोमिनेटर में 0 बनता नजर आ रहा है. Something like that here. So for this kind of a problem, we have to just take a assumption like a let cos inverse of x is nothing but t here. Function को change कर लेते हैं हम यहाँ पे. Okay. So what is x right now? We have a x is nothing but cos t, right? So as limit x tending to 1 by root 2. So what will be the limit about like t? T कहाँ tend करेगा? Yes, t would be like a 1 by root 2, pi by 4 here. Correct? So our question will be limit x, not x. This time we have a limit t tends to pi by 4, sine of t minus cos t divided by 1 minus tan t. Correct? I'll try to solve it. Sin t minus cos t upon 1 minus tan t. Yes. Can we apply sin c minus sin cos t? Something like that. Okay. Yes, you can try. You can try here, but it will become so easy this with the help of this step here. Like अगर आपको कहीं पे भी repetition दिखता है, like कोई function repeat होता है, तो आप वहां पे substitute कर लें. It will become easy. So we have a limit t tends to pi by 4. We have a sin t minus cos t divided by 1 minus sin by cos. Again, we have a limit t tends to pi by 4. We have a sin t minus cos t divided by what? Cos t minus sin t into cos t. It will cancel out minus 1 time. Yes, अगर आप minus common लेंगे, it will become cos minus sin. Correct? So we have a limit extending to pi by 4 cos of t here. So easy. Just substitute the value here. Pi by 4, 1 by root 2. So we have minus 1 by root 2. Okay. All right. Just note it down. Okay. Clear? Very good. So these are the questions we have here today. All right, students. So कुछ होमवर्क के लिए भी देते हैं यहाँ पे, जैसे कि यहाँ पे आपके पास एक क्वेश्चन नंबर 17. यस, इजी क्वेश्चन है, काफी आसान, आप इजीली ट्राई कर सकते हैं यहाँ पे. लाइक वी हैव अ लिमिट एक्सटेंडिंग टू 0 cos of sin x minus cos x divided by x raised to power 4. So at the numerator you can apply cos c minus cos d. आप यहाँ पे cos c minus cos d को अप्लाई कर सकते हैं. क्लियर? Yes, this is the hint given here. So you can use the hint and solve it. Okay? Yes, you may apply. Even ये वाला भी है, क्वेश्चन नंबर 18 भी है. Yes, you can apply. You can check it out here. Like we have a function abc belong to R, and then greatest integer of t as well is given there, so you can solve it. Yes, at x equal to 0 और x equal to 1 पे भी आपको चेक करना होगा, remember. Then find the option accordingly. Find the option accordingly. So don't forget to do your homework as well here. Yes, don't forget to do your homework here. Question number 19 भी काफी easy है, काफी आसानी से आप कर सकते हो. लिमिट एक्सटेंडिंग टू 1 x स्क्वायर माइनस 1 साइन स्क्वायर पाई x डिवाइड बाय x raised to power 4 minus 2x cube plus 2x minus 1 is equal to what? So again one of the easiest we have here. Yes, कुछ नहीं करना है क्वेश्चन में. Look at here at the denominator को आप फैक्टराइज कर लेना है. ओके, इसका फैक्टराइजेशन मैं आपको बता देता हूं. x स्क्वायर माइनस 1 एंड x माइनस 1 स्क्वायर. सो न्यूमरेटर में ये कैंसिल हो जाएंगे टर्म एंड देन यू मे वर्क ऑन इट साइन स्क्वायर पाई x अपॉन x माइनस 1 होल स्क्वायर. इधर यू कैन अप्रोच द लिमिट x माइनस 1 इक्वल टू h, आप ये कर सकते हैं. अदरवाइज आप यहाँ पे ये कर सकते हैं कि एल हॉस्पिटल रूल अप्लाई कर सकते हैं. लाइक लिमिट एक्सटेंडिंग टू 1 वी हैव हियर साइन स्क्वायर पाई ऑफ x बाई वॉट x माइनस 1 होल ऑफ स्क्वायर. आप यहाँ पे 2 बार एल हॉस्पिटल लगाएंगे, आपका आंसर आएगा. डेफिनेटली यू विल गेट योर आंसर. ओके, यस. सो काफी सारे क्वेश्चन है जो आपको मैं होमवर्क के लिए दे चुका हूं. कम से कम 4 से 5 क्वेश्चन हो चुके हैं. यस, सो आपको होमवर्क करना है और अपना आंसर कमेंट बॉक्स में करना ही करना है. क्लियर? एग्जैक्टली. अगेन सेम थिंग वी नीड टू अप्लाई. सेम थिंग पाई बाई 4 है, इस क्वेश्चन में भी कुछ नहीं करना है. सिंपल एल हॉस्पिटल को यूज करना है. करेक्ट, एलएच रूल को अप्लाई करें, यू विल गेट द आंसर. 8 रूट 2 माइनस कॉस एक्स प्लस साइन एक्स 4 पावर 7 डिवाइड बाई रूट 2 माइनस रूट 2 साइन 2x. Just apply L hospital, you will get the answer. Okay, all right. So yes, we have done at least 20 question today here. कम से कम 20 क्वेश्चन के. yes, 4 से 5 होमवर्क दिए हैं मैंने. सो करना क्या है, आपको अच्छे से सॉल्व करना है और उनके जो नंबर्स हैं लाइक क्वेश्चन नंबर 18 और 19 इस तरह के होमवर्क है. क्वेश्चन नंबर 18 आपको ऑप्शन ए बी सी डी वहां पे जरूर मेंशन कर लेना कि कौन सा ऑप्शन करेक्ट है. ओके, सो नेक्स्ट क्लास में हम उसके बारे में और अच्छे से डिस्कस कर लेंगे. क्लियर? ऑलराइट. सो व्हाट नेक्स्ट? एग्जैक्टली. सो यस, सी यू इन नेक्स्ट क्लास हियर स्टूडेंट्स हियर एंड ऑल द बेस्ट फॉर योर जेईई एग्जाम. काफी कम दिन बचे हैं और कुछ इंपॉर्टेंट चीजें हैं जो मैं बताने वाला था. एग्जैक्टली, डाउनलोड द ऐप हियर, एप्लीकेशन एज वेल एज व्हाट यूट्यूब ऑल्सो. यस, एप्लीकेशन और यूट्यूब दोनों ही जगह पे लगातार बने रहिए, आपकी क्लासेस चलती जा रही हैं. ओके, ऑलराइट. सो वी हैव एम्बाइब वीएलई ऐप एंड एम्बाइब ऐप एज वेल एज एम्बाइब लेंस ऐप ऑल्सो. सो एम्बाइब लेंस ऐप में क्या करना है, सिंपली इफ यू वांट टू सी द 3D मॉडल सिंपली क्लिक द पिक्चर एंड यू विल गेट एवरीथिंग. यस, एवरीथिंग विल बी अवेलेबल देयर. ओके स्टूडेंट्स, यस. एंड यस, वी हैव अ टेलीग्राम चैनल एज वेल एज व्हाट्सएप फॉर doubt resolution here. So if you have a doubt, you can clear at WhatsApp. Even the link is already given in a Telegram here. You can join it and yes, whatever we have done throughout the class, everything will be available there. All right, students. So this is Sheikh Rafique signing off. See you in our next class. Thank you. Thank you so much. And don't forget to like, share and subscribe. Take care all of you. Bye everyone. See you in our next class.